Hello, this is Mr. Collier, and today I'm going to do volumes of revolution using calculus. So volumes of revolution means you can think of a function as like kind of rotating it around the x-axis, and it creates a 3D object, right? Like if you rotate this line around the x-axis, you make basically a cone, for instance, right? So you can think of this cone as an infinite number of circles added together, and that gives you the volume. That's the idea behind the formula. Okay, so for each of these circles here, or these are disks because they have some thickness, notice like the radius is like the y value of the function. And for each of the disks, the area is, pi r squared. This is the formula for the area of a circle, right? Pi r squared. So this will be pi times y squared is the area of each circle. So what the integral does, if you have a starting value and an end value, you just like add up an infinite number of circles between those two values, and it gives you the volume. So that's where the formula comes from. This is in your formula booklet. So to find the volume, first of all, let's consider what it looks like. The function, this is root x. Okay, so you've got root x from 1 to 4. 1 to 4, if we take that area and we rotate it around the x-axis, we get a shape like a bowl. Okay, let me try to draw the 3D shape that we would get. You get like a shape like this, like a bowl. So what's the volume of it? Well, you can just do volume equals, and I often factor out the constant pi. So the integral from 1 to 4, y squared, don't forget the squared part, so this is just root x squared. Okay, which is a very easy integral to do. This is just the integral of x, so it's just half x evaluated from 1 to 4. So that equals, take the half out, I suppose, pi over 2 times, oh sorry, that should be squared there, times 4 squared minus 1 squared, which equals 15, so it's just 15 pi over 2 is the volume of the shape generated. And you could derive all the formulas, or many of the formulas in your formula booklet, like the formula for the volume of a sphere. It all comes from calculus. So you can think of a sphere as like this quarter circle rotated around the x-axis gives you like a hemisphere or half sphere, right? Okay, so if this is the radius of r, then our volume for the sphere generated when you rotate around the x-axis is pi times the integral from 0 to r, and you need to know the formula for a circle. A circle is x squared plus y squared equals r squared is the graph of a circle. So to get this little graph here, you just solve for y and you do the square root. So this is the square root of r squared minus x squared is this graph right here. So that's the function that we're rotating around the x-axis. Okay, so we do that integral and we square it, and the square root cancels. Oh, by the way, we need twice this area because that just gives you half of a sphere. So we have 2 pi, and now the integral of r squared. R squared is a constant. You're integrating with respect to x, so it's just r squared x minus 1/3 x cubed evaluated from 0 to r. So it's 2 pi. Now we sub in r. We have r squared times r minus 1/3 r cubed. And that's r cubed. So r cubed minus 1/3 r cubed is simply 2/3 r cubed. So multiplying that together, we get 4/3 pi r cubed, which is the formula for the volume of a sphere. Okay, now this is some more explanation of the volume formula, but if we have sometimes we need to subtract two functions. Like for example, this one's got a hole in it. You would take this function and subtract the hole. So that's what the formula looks like if you have to subtract two functions. Okay, so we're going to do that in this example here. What does it look like first of all? Well, y equals x squared is here. Root x looks like this. So we're taking this and rotating about the x-axis. Okay, you're going to get a funny looking bowl shape. But we need to find the point of intersection. I think that's obvious that that is 1, 1. Okay, if you set these equal to each other, then 1 is a solution. So we're looking for the pi times the integral from 0 to 1 of top function squared minus bottom function squared. So that's root x is the top function. The bottom function is x squared. So this is what we're doing. Okay, so this equals pi times half x squared minus 1/5 x to the power 5 evaluated from 0 to 1, which equals pi times basically half minus 1/5, which is, now half minus 1/5 is 5/10 minus 2/10 is 3/10. So it's 3 pi over 10 is the exact volume created. Okay, in the next example, find the volume of the solid generated. Okay, so again, we need to see the picture. In this case, this is a parabola. It's above the x-axis and over the interval 0 to 2. Sorry, we need the function y equals x is here. So the area between 0 and 2 is, well, there's 0 and there's 2 somewhere. We're talking about this area rotated around the x-axis. So it is equal to, the volume is equal to pi times the integral from 0 to 2. Top function here is the parabola. All right, so if we do that, we get, well, let's just do that whole thing on the calculator. Let's click here and here, and then we've got 0 to 2, and we got half plus x, plus x squared. Okay, squared again, and then minus x squared. You have to put the x at the end and click enter, and you can even change that into a fraction if you want by clicking this button. So 69 over 10. So the answer is 69 over 10 pi.